Hello and welcome to the class. In the last week, we studied the data collection process where we learned about different types of variables and different types of studies. Now, suppose you have collected the data. So now it is important for you to summarize that data. Hence, in this week, we are going to learn different summary measures. Since there are two different types of variables, that is categorical and numerical, so we will begin this week with the summary measures for categorical variable. Then we will move on to the summary measures for numerical variable, where we will learn about the measures of central tendency, measures of dispersion, measures of skewness, and finally, we will implement these concepts using Python. So let us begin with the summary measures for categorical variable. Now, first of all, let us recall what is a categorical variable. Categorical variables are those which basically divide the data into different categories. So if you can recall from your first week lecture, there we considered an example of a class, and there we had a categorical variable as the eye color. So the eye colors can be categorized as either black, brown, green or hazel. Now see that this variable, that is eye color, it is a categorical variable and it has different categories. And you have collected the data from the class, but now you want to summarize that. In order to do that, you can either begin with the count. So the first measure of a categorical variable is count. So where we all know that count is basically the number of times a particular category appears in the data set. For instance, if you have the eye colors, so it will count how many times you have brown eye colors, then it will count how many eyes color are black, and likewise. Next, you can have the proportion also. So proportion basically gives you the percentage of observations that belong to the category with respect to the total number of observations in that data set. And last is your mode. It is basically the category that appears most frequently in the data set. So you have eye color. So the eye color can be black, brown, green, hazel. And in the class, you had suppose 50 students. So if you have to make the count for this, so first of all, you will count how many students have black eyes. So for that, suppose it comes out as 20. And for brown, it is 25. And the count for green comes out to be suppose 2 and hazel is 3. Right? So this is the count, because count is basically just the number of times a category appears in the data set. Right? Next is your proportion. So proportion is basically the fraction that particular category appears relative to the entire data set. So 20, and we will divide by the total number of observations, that is 50. Similarly, you can calculate for other categories as well. And the third one is your mode. So mode is the most frequent observation. So in this case, you see that brown appears as the maximum number of times. So the mode over here is brown eye color. So whenever you have a categorical data set, so you can either use count, proportion or mode to summarize that data. And it is very simple, and I believe you all know these and have used it in earlier works. So now let us consider an example over here. Suppose you conducted a survey among a group of your friends to determine their favorite pizza topping. For this, you have the given data set. So you asked different friends. So you have suppose 9 friends in this table. So, and you have asked them their favorite pizza toppings. So they have marked, you can see that what are the categories over here? Pepperoni, mushrooms, olives and onions, right? So favorite topping is basically a categorical variable and you have collected the data on it. Now you want to summarize it. And as we have seen just now, we can either use count or we can use mode or proportion. So let us start and see this example. Let us go with the count. Then you can count the number of times pepperoni appears. So it is 1, 2, 3 and 4. So 4 is the count for pepperoni. For mushrooms, it is 2. Olives also it is 2. And for onions, it is 1. So as you can see over here, these are the counts. And the total number of friends is 9. So proportion is basically 4 over 9, right? 4 by 9, 2 by 9. And for this onions, it is 1 by 9. And last, mode. So you can see that pepperoni is the one which appears the maximum number of times. So the mode over here is basically pepperoni. Okay. So whenever you have collected a categorical data set and you have to summarize it, remember that you can use either of these. You cannot use other like mean or median. They won't make any sense over here. So that is why, as I emphasized in the last week also, that distinguishing between numerical and categorical variables is very important, because as you move ahead in the course, you will realize that the summary measures or the visualization techniques and further the analysis also differs for these two types of variables. So if you distinguish between them properly, then it would be easier for you as you move ahead in the course. We move on to the summary measures for numerical variables. So numerical variables, we have seen that it can be either of discrete type or continuous types. So the first summary measure for numerical variable is the measures of central tendency. Basically gives you the idea about the central aspect of the data. What is happening in the middle of the data. So the most common measure for that is mean. Mean, we all know, it is just the average of the data. You add the observations and divide by the total number of observations and you will get the mean. The other one is the median. So median is basically the middle value of the ordered data. Whatever the data set is given to you, you arrange it in an ascending order and then you look at what is the middle value. So basically, median divides the data set into two halves. And finally, mode is the value that occurs most often in the data. To understand this, let us consider an example. So let us start for the numerical variable. Suppose the data set given to you is the attendance of the students in a class. Because in the last week also, we had such an example. Sample was given from a class of students. So let us consider that the attendance for 9 students is given to you, suppose. So let us take it as 22. Suppose 3 students have this, and then you have 24, 25, 28, 29, 30 and 30. Okay. So these are, you can see that there you have 9 students. Okay. Data on attendance is given. So out of 30 days, how many days they were present, that is given to you. Now you want to calculate the mean. So we know that mean is what? Mean is just basically 1 over n summation xi's, where I goes from 1 to n. So here n is your 9 and you just substitute these. So xi's are basically these observations. So this is x1, x2, x3, x4 and so on. So 22, and if you keep on adding and then if you substitute it, so you can add it and see that it comes around 232 divided by 9, so which is basically it is approximately 25.7. Okay, you can cross check this. And now median, if you want to calculate median For this, you need to arrange the data in the increasing order and in ascending order, and then you have to look at the mid value. Now, since here we already have it in ascending order, we can just look at the middle value. So here, if you see, 25 is your mid value because four observations are to the left of it and the remaining 4 are on the right of it. So median is 25 in this case. Because here in this data set, you have odd number of observations. If you have an even number of observations, then what you do is you take the average of the middle two values, right? So I believe you all are familiar with these. So that is why I am not going into much details about these aspects, and I'm just quickly summarizing it. And then mode is the value that appears most often in the data. So here you can see that it is 22, right? So mean is there with you, median and mode. So you can see that mean is the highest one, right? And then you have closely followed by median, and then mode is the smallest one. Now, since you have 3 measures of central tendency, it is important for you to distinguish and understand that which measure should be used in which particular situation. So, for instance, when is it better to report the median as compared to mean? You can consider a 5-employee small firm and their salaries are as follows. So you can see 35,000, 33,000, 45,000, 40,000 and 2 lakh. Now, if you want to take the mean of this, you will get it somewhere approximately around 70,000. And if you see the median, because if you arrange it in an ascending order, you will get the median as 40,000. Now, if somebody asks you, what is the typical salary of this firm, and you quote the mean, that is 70,000, then it might give an impression that most of the employees would be having a salary around this 70,000 only. However, the actual scenario is that their salaries are around 40,000. What is happening over here? Here, if you see that you have one observation, that this one salary is very high, maybe it is of some CEO. That is why what it is doing, it is pulling the mean towards itself, towards a higher end. This reflects that mean is very much affected by the extreme observations. It can be either a higher observation, very large one, or suppose if your salaries were around 50,000 or 55,000 and one of the employee's salary is suppose 5,000, then that will also pull it down. So in such cases, you have extreme observations, it is better to report the median and not the mean. Because in the presence of extreme observations, mean is likely to be affected, as you have seen here. So you have to be careful whenever you are reporting the summary measures, either mean or median. So first of all, identify and understand the dataset and see if you have outliers or extreme observations present in your dataset, and then only you summarize the data. Next, mode. Mode, as we have already seen earlier also, mode is mainly used for categorical variables. Also, if you talk about numerical variables, then also you can see that it is not a good measure when your data is continuous, because you can consider an example over here where you have the daily conversion rates of dollar to INR. So for these rates, if you see here, these values are so close to each other that it is difficult to find a mode in such cases. So we do not prefer mode for your continuous variables and also overall in general for your discrete variables also. So mode is mainly used for categorical data sets. You have studied about mean, median and mode. That is the 3 measures of central tendency. Now, one might think that, okay, so I know the measures of central tendency, I know about the central aspect of the data, so that is sufficient for me and I should not study any further measures. So to understand this, let us consider the salaries of two firms. If you see these salaries and calculate the mean over here, you will find that the means for the two firms is same. So the average salary of the two firms is same, that is 46,428, and the median salary also for both of them is 45,000, because 45 is the mid value over here. Okay. Now what it says is that if you just know about the central aspect of the data, that is if you have the knowledge only about the central tendency, then how would you compare the salaries of these two firms? Because both the means are same and the medians are also same. Okay, so this shows that you need some other measure also which would capture what is happening in the data set, because the values are different, that is evident from here, but their means and medians are same. Okay, and that is why you go to the next measure, that is measures of dispersion. Measures of dispersion basically tell you how spread out or dispersed your data is. And the first one in this is range. The next is your interquartile range. And then you have the most common one, that is standard deviation and variance. So range is basically, as you know, it is just the difference of the maximum and the minimum. Whatever data set is given to you, you just take the maximum value and the minimum value and take the difference, and you will have the range. So in the previous example only of the two firms, although their means and medians were coming out to be the same, if you look at their range, then it comes out to be 15,000. Okay? Because if you go back to that example, here you can see that 55,000 minus 40,000, that is the lowest, that is gives me 15,000, and here 65,000 is the highest and 30,000 is the lowest. So the difference gives me 35,000. Okay, so your range is different for the two firms. The only thing is that range, although it is very easy to calculate, it is very much affected by the extreme values, because if I change the last observation, if I just make it bigger and bigger, obviously your range is going to be affected by that, because it is just depending upon the smallest and the largest observation. So it is not such a robust measure of variability, and it is only focusing on the two ends, that is the two extreme observations, right? So next one, that is interquartile range, it focuses on the middle 50% of the data set. And to understand interquartile range, we need to first understand what is a quartile. If you have a data set which is ordered from smallest to largest, basically reflects that P% of the data is below that, and at most 100 minus P% is above it. So let us understand what is, suppose your data looks like this, then Pth percentile over here, we say that this point is your Pth percentile. If P% of the data is below this point, so this is P%, and the remaining is, this is 100 minus P%. So if I want 25th percentile, it means that 25% of the observations are below it and 75% are above it. Similarly, I can have the 50th percentile also. Then 50th percentile means that both sides we have equal distribution of the data, that is 50% on both the sides. Similarly, you can consider the 75th percentile also. So 75% will be below this and the rest 25% will be above it. And this basically 25th percentile is referred to as your first quartile. So for quartile, we use a capital Q and we give a suffix 1, which basically denotes it is a first quartile. So first quartile is same as your 25th percentile. Okay. So here, this is Q1, and then your 50th percentile basically, what is it? It is the second quartile. And it is in fact the median because it is dividing the data sets into two equal halves, 50% above and 50% below. So it is your median. Q2 is your median. And Q3 is basically your upper quartile, that is 75th percentile. So this is lower quartile, this is upper quartile. It has another name, that is first quartile, second quartile, mid, and this is third quartile. Okay. So if I need to draw this, so how it will look like? So this is median. So this will be Q2. This side it will be Q1 because here you have 25% and here it will have Q3. Right? So 25% is below this. 50% is below this point. Below Q2, this is 50%, right? So it means here you have 25% and here also you have 25%. Now here you have 75%, which again means that in between this you have again 25%, and finally above it you will have 25%. Okay, and this gives you the IQR, that is interquartile range, because IQR is nothing but the difference between the third and the first quartile, because third quartile is 75th percentile over here and this is the first quartile, which is 25th percentile. So here if I look at the difference of these two quantities, it means I am focusing on the middle 50% of the data set, this data set over here. So middle 50% of the data is covered by IQR. Okay. So here you see that it is not affected by the extreme observations because it is not even considering those extreme observations in its calculation. Whereas range is getting fluctuated a lot because it depends upon the extreme observations. That is just simply the difference of maximum observation and the minimum.